I'm so sorry friends that I just forgot to shift my camera over here, but I strongly recommend you all to see the previous video and write down the notes of it, because we will be using certain equations over here in this derivation what we have already done into the previous board, right? So let's begin again. The way I have told you, we people have calculated the value of IR. We are going to calculate the value of IS by putting all the different values of A, B, C, D and VS and VR. Fine. Then after we have got the value of IS like this. Now we are interested to calculate what is sending end power. So sending end complex power is, it is receiving end complex power is given by VR into IR conjugate. Now we have already got the equation of IR into the previous board. In the previous video you people have seen it. So you can see when I have to go for IR conjugate, I'll be just taking the negative of the angle what it has. What is the meaning of conjugate? If you have 3 plus J4, the conjugate of it is 3 minus J4. So ultimately, magnitude and angle, if you say, it is, say mod, say if it is magnitude angle at an angle phi, so I can say that the conjugate of this particular number is given by magnitude same, conjugate is nothing but at an angle minus phi. Fine? Because it becomes m cos phi minus jm sin phi. So I hope you know the concept of conjugate. So in our IR, I was having delta minus beta over here. So I have taken a conjugate and hence it became beta minus delta. Here I have mod A, mod B or mod B, and in my previous board I have written that it is alpha minus beta, but I am writing over here which is beta minus alpha because I have taken a conjugate over here. Now say receiving end power is given by VR IR conjugate. VR I have kept, entire IR conjugate I have kept over here. I am so sorry. This is VS and this is VR. So VR VS beta, VR VS B, VR VS B 0, and this is beta minus delta. This is beta minus delta. Minus A VR B is already there, and this VR will also get multiplied. So I'll be having A VR square and B was already there. Beta minus alpha, just because VR is having 0 angle, so it is not getting added over here. Fine? Okay. Now when I talk about magnitude at some angle, so this angle will be having two components. One is cosine component and one is sine component. Cosine component is a real component and sine component is an imaginary component. Similarly, we have this angle over here which has cosine and sine component, where cosine component is real component and sine component is imaginary component. So I know S is complex power, which is equal to P plus JQ. Fine. So I can say that P is nothing but the real part of it and Q is nothing but the imaginary part of it. So I can say that cosine of beta minus delta is multiplied with this magnitude and cosine of beta minus alpha is multiplied with this magnitude. It will give me total receiving and active power, which is equal to VS VR upon B, VS VR upon B, cosine of beta minus delta and A VR square upon B, A VR square upon B into cosine of beta minus alpha. So this is where I have got my active power. For finding the reactive power, we will be taking the sine component over here. So VS VR upon B sine beta minus delta, VS VR upon B sine beta minus delta, minus it is A by B into VR square, A by B into VR square sine of beta minus alpha. We got this. Now let's find the sending end say power, apparent power. So I have to find out IS conjugate. That you can simply do that. You have to just repeat the process, nothing else. You have to just take the negative of the angle given over here. Then SS is nothing but VS into IS conjugate. So VS, which is at angle delta, and IS conjugate. What I have taken over here, I am writing it as it is. Then what I have done, I have multiplied it inside. Delta will get cancelled out. I have got beta minus alpha, and here VR VS upon B. Here what will happen? D VS square upon B. So similar things we have followed, and we got sending and active power and receiving and active power. So you people have studied this theory at engineers classes. I am Anand Panchbhai. Adios. Hasta luego.